Hi guys, today I want to show the example of astrick algorithm, and the problem is, so this is the problem. This is a chessboard, and this is the start box, and this is the end box, and we want to move the knight. So the move of the knight would be something like this, and we want to move the knight from here to here, and we want to get the smallest distance, the optimal distance with astrick algorithm, or the smallest path, not the distance, smallest path with astrick algorithm. Okay, let's begin. First what we do is we have to define some heuristic for it, and this is the heuristic function. The first heuristic would be h1 equals to number of lines between the end node and the current node divided by 2. What it means is, if this is your current node, then the heuristic says it's the number of lines is 1, and 2, the number of horizontal lines. If it is this, and number of horizontal lines is 1, 2, 3, and heuristic says it's a number of the ceiling of horizontal lines divided by 2. Or another heuristic you can define is the horizontal lines plus the vertical rows divided by 2. And heuristic you can use, but for our case I use this heuristic. And we also have to define the first model. So this is if we go from a node to another node, that is its successor node, then fn would be gn plus hn. This is from the astrick algorithm itself. And gn would be, we define gn as the gn of the parent plus the cost, and the cost of going from n to n, that is from parent to the successor, is always 1, and g of start node, that is s, is 0. Okay, let's begin. So first what we do is we put this s to the open node, and we go to s. Then we expand s and put s to the closed node. But before that first we calculate the value for s, that is fn of s is gn, that is g of s is 0, and h1 of s is its s is 1, 2, 3, 4 distance. 4 by 2 is 2, so fn is 2. Then we expand fn, we put to s, and we put s to the closed node, and we expand fn. So the possible nodes that we go from s, it would be a, then we can go here, we can go here. So it's abc. We put abc to the open list, and of course the pointer of abc would be pointing to s. Now what we do is we have to calculate the value for abc. Okay, let's begin. So what would be the fn of a? Fn of a is g of a plus h1 of a, and g of a is g of s, that is the parent, plus the cost of going from s to a. G of s is 0, we see from here, g of s is 0, and c is 1, gives you 1. And what would be the h1 of a? A is 1, 2 distance away, and 2 divided by 1 is h1a is 2 distance away, and it gives you 1. So we write 1 here, and it's 2. So similarly, b would be also g of b would be also 1, because it would be the same. G of b is again g of s plus going from s to b, and this is 0, this is 1, gives you 1, it's exactly the same because this is always 1. So all the successor will have the same g value. So from now onward I will simply write the same value without showing this calculation. So it's 1, and obviously c will be also 1, and b is 1 and 2 distance away, so it would be again 1, and c is 3 distance away. 3 divided by 2 is 1.5, and the ceiling will make it 2. It's 2, and when you add, then it gives you 3. Now we have to choose the candidate, the successor for S, the next candidate. And the AV, out of ABC, AV has the smallest value, and we choose A. So we choose this A, so we remove A from here, and put it to the closed list, that is here. And obviously the pointer is still pointing to S. Now we go to A, and just not to be confused, I'll make it bold. It's A, B, C. Now we expand A. From A we can go to here or here. E, then here. Yeah, now we put those things in the open list, that is D, E, F, and they are again pointing to the node A because they came from A, and we calculate the value E, F. And the G of D, what would be the value of G of D? G of D would be the G of the successor, G of the parent, that is G of A plus 1, that is the cost. So G of D would be G of A plus the cost, that is 1. G of A was 1. So it's 1 plus 1 gives you 2. So G of D is 2. So similarly, G of E would be 2, and G of F would be also 2. And H1 of D is, the D is in the same distance, in the same line as X, so there is 0 distance between D and X, and it gives you 0 because 0 divided by 2 is 0. And what about E? E is 1 distance away, so this is E, it's 1 distance away. 1 divided by 2 gives you 0.5, and when you do ceiling, then it gives you 1. And what about F? F is 1 to 3 distance away, so 3 divided by 2, 1.5, make it ceiling, gives you 2. So when you add, then it becomes 2, it becomes 3, it becomes 4. Now since D has the smallest value, we choose D for the expansion. So we go to D, and just not to be confused, I'll make it bold. Now we go to we expand D. Yeah. So from here we can go to here or here or here or here or here. So we put the expanded thing into the open list. So we first put G H I yeah, GHI, then B, and A is already in the closed loop, so we don't we ignore A. So what is the value for Z? Sorry, there's one J also missing. Yeah. So I, J, and B. Now what is the so this is the important part. So first I don't put immediately it into the open list. I put it manually. First calculate and put it into the open list. So first, what is the f value of g? F value of g would be the parent. It came from A. Oh no, it came from D. Right? Yeah, because we choose D. So it would be f of D would be gn. So gn of D would be 2 plus 1. It gives you 3. So same for all. And the distance is 1 divided by 2 is with the ceiling gives you 1, and similarly it is again h is 1, I is also 1, j would be again 1, and b would be again 1. So it all of them gives you 4. Now here's the point. Since g is not in the open list, we put g. H is not in the open list, we put H. I is not in the open list, we put I. J is not in the open list, we put J. But B is already in the open list, so we decide whether to put B or not. If you see, the old B was this, and it has the f value of 2, and new B is this, and it has f value of 4. 4 is greater than 2, so we discard this B. So we don't put this B to the open list, the new B. Instead we say, okay, this is we take the old B as a candidate. So G is pointing to D, and this D is pointing to D, this is pointing to D. We don't put B, but B is pointing to S. So these are the candidates, new candidates, and out of them, so these were the candidates, and out of those B has the smallest value, so we choose B. So we go to B and we put B to the closed list. So B goes here, and remember, it is not pointing to D, but it is pointing to S. Yeah, so that's the big difference, because all the successors are pointing to D, but this B, even it came from D, it is pointing to S, because we are taking the old B which came from S. Okay, now let's expand. It's the same process again. So we expand B. So possible would be going from here. We can go here, L. Then we can go, yeah, M. First, just not to be confused, I'll make it bold. I, G, yeah. So I can go from B to here, here, then to here. M, N, O, P. Yeah, these are the possible paths of B, and we have to put it into the, again, in the open list. So that is L, M, N, O, and P, and they are all pointing to B. And we have to again similarly calculate the values for those L, M, N, O, P. And similarly, while calculating, we'll get the values 2, and this will be 1, this would be 2, this would be 0, it gives you 2, and it would be 2, 1, 3, this would be 2, 2, 4. And this would be 2, 2, again 4, and out of it M has the smallest F value, so we choose M. So we go to M, it's this, and we check if M is a goal. Since M is a goal node, we put M to the close node, because we go to M, then we check if M is the goal node. M is the goal node, so we stop the algorithm. So this is the optimal path. So for optimal path we do like a backtracking. Sorry, M is pointing to B. Yeah. So for optimal path we do backtracking, that is M, then M came from B, and B came from S, that is the start node. So this is the optimal path, that is we go from here and here. Yeah, this is the how astrick works. Hope you got it.